Islands often look peaceful, but isolation changes nature in dangerous ways. When animals are trapped with limited space and food, evolution does not slow down, it becomes harsher. Over many generations, survival favors extremes, not balance. This is why islands so often produce strange, oversized, or unusually aggressive animals. Popular stories imagine such places as Skull Island, but the real world has done this before. In Earth's deep past, one island followed these rules to terrifying extremes. That island is Madagascar, seen not today, but 70 million years ago. By the late Cretaceous, Madagascar was already isolated from Africa by over 250 miles, or about 400 kilometers, of ocean. This separation meant animals could no longer move freely between landmasses. Earlier, Madagascar had been physically connected to India for tens of millions of years. That shared history lasted longer than the entire time between modern humans and dinosaurs. When the land finally split, animals from India were left behind on a drifting island. From that moment on, Madagascar became a closed, evolutionary system. No new large predators arrived. No large herbivores followed. Every species had to survive using only what was already on the island. Space was limited, but competition was constant. Over time, island evolution pushed animals toward unusual body shapes and behaviors. Some species became smaller to survive on less food. Others became larger and more aggressive to dominate limited resources. Madagascar was large for an island, but not large enough to stabilize its ecosystem. Seasonal droughts regularly dried rivers and shrank wetlands. Then sudden rains returned, triggering powerful floods across the plains. Geological evidence shows floods strong enough to bury animals under layers of sediment. In this world, survival depended on strength, speed, or brutal efficiency. From this pressure-filled island, a single predator would rise above all others. The predator that rose from this pressure-filled island was called Majungasaurus. It lived during the late Cretaceous and was the largest known carnivorous dinosaur on Madagascar. An adult Majungasaurus reached about 23 feet in length, roughly 7 meters. Its body mass exceeded 2,000 pounds, approximately 900 kilograms, making it a heavyweight island predator. Yet, Majungasaurus was not built like famous mainland giants such as Tyrannosaurus. Instead, it belonged to a southern dinosaur family known as abelisaurids. Abelisaurids evolved in isolated regions where efficiency mattered more than versatility. One of Majungasaurus's most striking features was its extremely reduced forelimbs. Each arm measured less than 1.5 feet, roughly 0.445 meters, and could not grasp prey. As a result, killing did not involve arms at all. Majungasaurus relied almost entirely on its head, neck, and torso to subdue victims. Its skull was short, wide, and reinforced with thick bone layers. This structure allowed the skull to resist twisting forces during violent struggles. Rather than slicing repeatedly, Majungasaurus likely bit once and held on. This hunting style resembles modern big cats, which kill by control, not speed. Massive neck muscles stabilized the skull and absorbed shock during prolonged fights. The rib cage formed a rigid, tightly connected structure supporting the torso. This rigidity allowed Majungasaurus to press prey down using its own body weight. Its legs were thick and muscular, built as load-bearing pillars rather than running tools. Such legs provided balance on unstable ground like mud and floodplains. Majungasaurus was not a long-distance chaser, but a close-range enforcer. Its teeth were thick and curved, designed to withstand high stress without breaking. Fossil teeth show heavy wear, evidence of frequent feeding on large animals. Every feature points to one purpose: overpower large prey in brutal physical combat. But even a king needs prey, and Madagascar provided dangerous victims of its own. The primary prey of Majungasaurus were not small animals, but large plant-eating dinosaurs. These herbivores belonged to a group known as titanosaurs, long-necked relatives of giant sauropods. On Madagascar, the most common titanosaur was Rapetosaurus. An adult Rapetosaurus measured about 50 feet in length, or about 15 meters. It weighed roughly 15,000 pounds, approximately 7,000 kilograms, large but smaller than continental giants. This reduced size reflects island evolution, where limited resources constrain maximum growth. Despite this, Rapetosaurus remained heavily built, with strong legs and a massive torso. Its long neck allowed it to feed across wide areas without moving its heavy body. Juveniles were far smaller and more vulnerable than adults. Fossil bone beds show that young individuals were common targets for predators. Another titanosaur, Wahine, shared the same floodplains and feeding grounds. Wahine had a more lightly built skeleton, suggesting different feeding strategies. These titanosaurs often gathered near rivers during dry seasons. As water sources shrank, animals became concentrated into smaller areas. This concentration created perfect hunting conditions for large predators. Muddy ground reduced the mobility of massive herbivores. A struggling animal became an easy target for ambush predators. Fossil bones of Rapetosaurus show deep tooth marks matching Majungasaurus teeth. These marks confirm direct predation, not scavenging after death. Bite locations suggest attacks focused on limbs and soft tissue. Once immobilized, even a large titanosaur could be brought down. This predator-prey relationship shaped both species over generations. Titanosaurs evolved strong bones and size, while predators evolved brutal efficiency. But competition for food did not end with herbivores. On Madagascar, even the apex predator would face a darker reality. The darker reality was this. On Madagascar, even Majungasaurus became prey. Fossil discoveries revealed something unexpected inside predator bone beds. Some Majungasaurus bones bear clear tooth marks made by Majungasaurus itself. The dimensionalized spacing and shape of these marks perfectly match Majungasaurus teeth. This is not scavenging by another predator. It is confirmed cannibalism. Among non-avian dinosaurs, Majungasaurus is the clearest confirmed case of this behavior. Bite marks appear on limb bones, suggesting feeding, not combat wounds. The bones show patterns of defleshing, similar to how Majungasaurus fed on other prey. This means individuals were eaten after death or killed and consumed deliberately. On an island with limited food, cannibalism becomes a survival strategy. Removing a rival also removed competition for territory and prey. For large predators, this brutal efficiency can stabilize survival in harsh systems. Cannibalism likely occurred during droughts when prey was scarce and risks were high. Younger or weakened individuals would have been the most vulnerable. This behavior increased selection pressure, favoring faster growth and aggression. Over generations, this shaped a predator population with little tolerance for weakness. Cannibalism also explains why complete skeletons are rare in the fossil record. Bodies were often consumed before burial could preserve them intact. This behavior was not madness, it was adaptation under extreme pressure. On Madagascar, evolution rewarded ruthlessness. Yet, Majungasaurus was not the only monster shaped by this island. Beneath and beside it lived predators just as strange and dangerous. Some hunted in water, others in burrows or ambush zones. Together, they formed a layered ecosystem of constant danger. To understand this island fully, we must explore its other predators. Beyond Majungasaurus, Madagascar hosted a diverse community of predators. Some ruled the rivers and wetlands, where water itself became a weapon. Among them was Majungasaurus, a terrestrial, crocodiliform, adapted for land hunting. Unlike modern crocodiles, it had long legs and could move efficiently on land. Its body length reached about 10 feet or about 3 meters, making it a mid-sized predator. Majungasaurus likely preyed on small dinosaurs and other vertebrates. Sharing the island was another crocodiliform with a very different lifestyle. Majungasaurus was short-faced, armored, and surprisingly herbivorous. It measured about 4 feet in length, approximately 1.2 meters, but was heavily built. Its blunt teeth were designed for crushing plants, not flesh. This shows how isolation reshaped even traditionally carnivorous lineages. The wetlands also hid a massive ambush. Predator, a giant frog. Beelzebufo, sometimes called the devil frog, was among the largest frogs ever. It reached about 16 inches in length, approximately 0.4 meters, and weighed over 9 pounds, roughly 4 kilograms. Its skull was thick and powerful, capable of delivering a crushing bite. Beelzebufo likely preyed on small vertebrates, including juvenile dinosaurs. In the undergrowth, danger also came without warning from above and behind. Matsoya, a large prehistoric snake, coiled through forests and wetlands. Though its exact length is debated, it likely exceeded 16 feet, or about 5 meters. Matsoya likely hunted by constriction, overpowering prey silently. These predators occupied different niches, reducing direct competition. Together, they formed a tightly packed, multi-layered food web. On Madagascar, danger existed at every height and habitat. Even small mistakes could be fatal in such a crowded predator landscape. Yet this brutal balance would not last forever. The end came suddenly, not from Madagascar, but from deep space. About 66 million years ago, a massive asteroid struck Earth. The impact site lay near what is now the Yucatan Peninsula. The asteroid measured roughly 6 miles across, or about 10 kilometers. The collision released energy equivalent to billions of nuclear bombs. Shockwaves traveled around the planet, triggering earthquakes and tsunamis. Even distant Madagascar was not spared from these global effects. Debris blasted into the atmosphere, blocking sunlight worldwide. Photosynthesis collapsed as darkness spread for months. Global temperatures dropped rapidly, creating an impact winter. Plant communities failed first, removing the base of food webs. Herbivorous dinosaurs soon followed, unable to find enough food. Large predators like Majungasaurus were doomed shortly after. Size and specialization became fatal disadvantages in the new world. Fires ignited across continents as heated debris rained down. Acid rain followed, damaging soils and freshwater systems. Madagascar's rivers and wetlands collapsed under this stress. Fossil evidence shows no dinosaur species survived on the island. Entire ecosystems that took millions of years to form vanished. Madagascar experienced a complete biological reset. No land animal alive today on Madagascar descends from the Mesozoic era. The island would later be recolonized by survivors arriving long after the disaster. These newcomers faced an empty land shaped by extinction. The monsters were gone, but the island's power to reshape life remained. To understand that legacy, we must look at what came after. After the extinction, Madagascar was silent, an island emptied of large animals. Forests slowly returned, reclaiming land once ruled by dinosaurs. With dinosaurs gone, ecological role stood vacant for millions of years. Life would return, but not immediately and not easily. Madagascar remained isolated by hundreds of miles of ocean. Any animal reaching the island had to cross water by chance alone. Some mammals likely arrived on floating mats of vegetation. These rare arrivals found an island with little competition and many empty niches. Over time, they diversified rapidly, adapting to island conditions. Early mammals remained small, avoiding the risks that doomed larger species before. Birds were among the first vertebrates to recolonize the island. Some birds lost the ability to fly, evolving into ground-dwelling forms. Reptiles also returned, including lizards and early snakes. Each group evolved independently, shaped again by isolation. Millions of years later, the ancestors of lemurs arrived. With no monkeys or large predators, lemurs diversified into many forms. Some became nocturnal, others specialized in leaping or feeding on leaves. The same island rules repeated: isolation, specialization, and extremes. Madagascar once again became a laboratory of evolution. But this time, no giant dinosaurs returned to claim dominance. The age of monsters had ended, replaced by fragile balance. Yet, the island still carried the memory of its violent past. Fossils beneath the soil tell stories of a far harsher world. Madagascar reminds us that evolution can create both wonders and nightmares. And on islands, those transformations happen faster and more extremely. Madagascar today looks calm, but its biology still carries the island's ancient rules. Isolation never ended. It simply shaped new forms of life. Many modern animals here evolved from a small number of lucky colonists. With few competitors, these lineages expanded into roles filled elsewhere by many species. This explains why Madagascar has fewer species overall, but extreme specialization. Lemurs replace monkeys, filling niches across forests, trees, and ground. Some became tiny, others unusually large compared to mainland relatives. Reptiles followed similar paths, producing giant chameleons and highly specialized geckos. Even insects evolved strange sizes and behaviors under island pressures. The same forces that once shaped dinosaurs still operate today. Limited space means ecosystems remain fragile and easily disrupted. When balance is disturbed, recovery can take millions of years or never happen. Madagascar's past shows how quickly extremes can emerge. It also shows how quickly entire worlds can vanish. Today, the island faces a new pressure, one not shaped by geology or space. Humans arrived recently, but their impact has been enormous. Habitat loss compresses species into smaller and smaller areas. This mirrors the same pressures that once drove prehistoric brutality. But unlike the past, recovery time may not exist. Madagascar's history is a warning written in stone and bone. Islands amplify change, both creative and destructive. What happened here once could happen again in different forms. The monsters of the past were not evil. They were products of pressure. Today, pressure comes from choices made in the present. Madagascar reminds us that evolution listens and it never forgets. Looking back, Madagascar followed every rule that turns islands into biological extremes. Long isolation, limited space, unstable climate, and closed ecosystems. Together, these forces transformed ordinary lineages into brutal specialists. Majungasaurus was not an accident. It was an outcome. So were the giant frog, the land-hunting crocodiles, and the island titanosaurs. None of these creatures were monsters by design. They were shaped by pressure, scarcity, and survival. In many ways, Madagascar functioned like a real-world skull island. But unlike fiction, this island left behind evidence written in stone. Tooth marks, broken bones, and buried ecosystems tell the story. Science allows us to reconstruct this lost world with remarkable detail. Every fossil adds a sentence to Madagascar's forgotten history. This was a land where survival demanded ruthlessness, and where even kings were never truly safe. Yet, all of it existed within the normal laws of evolution. No magic, no curses, just biology under pressure. Islands amplify evolution the way lenses focus light. Small changes become dramatic outcomes. Madagascar shows us how fast worlds can turn extreme, and how fragile those worlds truly are. One impact from space erased millions of years of adaptation. Evolution builds patiently, but destruction can be instant. This balance defines life on islands. Madagascar is not unique. It is a warning written clearly. A warning we are only beginning to understand. Today, Madagascar is celebrated for its beauty and uniqueness. But beneath that beauty lies a far darker past. A past where evolution showed no mercy. Understanding that past helps us protect the present, because the same pressures still exist, only in new forms. Habitat loss, climate instability, and isolation return once more. On islands, consequences arrive faster and hit harder. Madagascar survived one reset, but survival is never guaranteed. Evolution does not protect what it does not need. It only responds to pressure. The monsters of the past were messages, not mistakes. Messages about limits, balance, and consequences. Madagascar tells us what happens when balance breaks and what can emerge when pressure goes unchecked. Islands. Remember these lessons better than anywhere else. They record them in bone, stone, and silence. Madagascar is not cursed. It is honest. Honest about what nature can do, and honest about what we risk repeating. In that sense, Skull Island was never fiction. It was a reflection of real evolutionary truth. A truth written most clearly on islands like Madagascar, where life becomes extreme and consequences arrive fast. This island turned animals into monsters and then erased them.